Vasanthi ma'am, are you there? Vasanthi ma'am, you there?
She's trying. We cannot hear the voice.
Can you hear my voice now?
Yeah, okay.
Yes, ma'am.
Okay, fine. How many of you? Yes, good
Which
evening
name
to
is yours,
everyone.
ma'am, in this Samsung SME236? So which name, ma'am?
What is that? Let me check.
Host, ma'am.
Host, actually, no, I am not a host. Nubia became a host of it now.
Yeah, just okay, no.
Okay.
How did I become host, ma'am?
I don't know. Now BRAU became a host.
Yes.
Okay. So how many of you are there? Still we have to wait or start?
7 people
Now
are
you
there.
are the host, ma'am. One second. You are the host now.
I am the host now. Okay,
Yeah.
ma'am. But my name is not reflecting. Why, ma'am? What could be the reason now?
Don't know, ma'am, actually. So now
Okay,
it's
no problem.
okay?
Okay, ma'am. Okay, thank you.
Okay.
Thank you.
Ma'am, when you're joining, there the name comes. You have to change your name over there.
Where I have to change?
While joining, when you put the ID number.
Hello. Ma'am. Ma'am,
you have to put your name over there.
Okay, next time
Simply taking your phone name. You have to change the name. Then you have to put the password.
Ma'am, you can change it now also, no problem.
Actually, every day when I started, I never changed, but it happened like that. In the past 2-3 times only it happened. So next time, let me do. Okay. This time, let us wait for some more time or we'll start.
We'll wait for 5 minutes and start, ma'am.
5 minutes. Okay. Now, what is 44? Okay, by 50 we'll start. Okay, now sure.
Yes, sure. So what Nubia told us correct only. 6:30 we start by 6:50.
Yes, that's right.
Hello.
Yes,
Hello.
yes.
Am I audible, ma'am?
Yes, audible. Yes.
Okay. Nothing, ma'am. I have some network issue, so I'm just going in and out. It's like for me. I was just checking, madam.
Okay.
Some internet issues are there.
Till now, if people have any doubt on the classes from the previous classes?
No, ma'am.
Very good students I have. They never have any doubt. Really?
Ma'am, just try if you can click on your name, no, here Galaxy M02. There they will give you the option to rename.
Okay.
If you click on the name, they will give you option to rename.
Yes.
But it will be done only for first meeting only. Every time you have to do like that.
My God.
Because you have to change. You have to change in your ID. I think this is from the phone ID. It is showing Galaxy. Now it has come your name.
Okay. How many of you are there? Only
7 people, ma'am.
Yeah, you not that. Okay. But anyhow, it is streamlined and all. All the regular students have joined?
Yes, ma'am.
Okay.
Ma'am, can we record your meeting?
I will send the link if people can. Why you are
recording. Ma'am, can we record your meeting?
You can.
Because we need permission from the host, it seems.
No, ma'am. I will tell you that why are you wasting the memory space of your mobile? I myself will give the link. From the link you can hear whenever you want.
Acha. Okay. Got it.
Okay. That's what these people are recording now.
Right.
University people are doing. Now Rajita madam is doing that job.
Rajita ma'am went away, ma'am. That's why she made you the host.
I'm telling you, already she put it in streamline.
Okay.
I used to get that. Yeah.
Yes, ma'am. It's live.
Yes, yes. Whatever we are speaking, everything will be recorded.
Yes,
Even
ma'am.
when I am cracking joke on you, scold on you, everything will be there.
Yes, ma'am.
Now you people, when you hear the video one more time, that time you will be laugh. I used to say, I will put a -2 for assignment. For that time, people will laugh.
Then, ma'am, you should give extra 2 marks for people who are doing.
That's what I said yesterday. No one was opening mouth. Okay, you may get that PPT from your, about in disinfection. You can open it. At least we'll start to discuss a little.
Okay, ma'am.
Why to waste the time? This Durgesh has not joined in regular class.
No, ma'am.
Bhargavi is there. Asha is there. Dalia madam is there. What about Harshita?
Harshita is also not there. I don't know why, ma'am.
She's not joining her.
I'll message her and ask, ma'am.
Hello.
Yes, ma'am.
Good evening. Are you attending the class or not? We are okay. We are waiting for you only. I think so. How many minutes? Okay, let us wait. Okay. Meanwhile, we will start discuss. Hello. Hello. People are hearing my voice or not?
Yes, ma'am. We can hear you.
Let us start.
Yes, ma'am. You can start.
Okay. So whatever the subject we have discussed till yesterday, have you gone through with your old question paper?
Oh, no, ma'am.
No means why I have to spend this much time for you people? Excuse me. You have to go through it parallelly. Then if you have any doubt, then you can ask no.
Yes, ma'am.
Like a school students I'm treating. I think next time onwards I have to bring the scale to beat you. You have to check the question. This and all in PG level, no one will ask. I told you in medical college and all how they are teaching for me PG students.
Yes,
Did I tell you? Even one of my friend was doing this BDS master degree, MDS, isn't it? She
yes.
said, I asked her, how was the teaching? How you people will cover the subject? They will cover the subject or what you do, everything. She said in a single sentence, here no one will teach. Okay, we only have to cover the syllabus by taking the seminar. We ourselves will distribute it, we take them. But they are taking in-depth classes. Based on that only they are giving marks, it seems. And also the recognition will be there, those who are doing good. Whatever the input they are giving on seminar, that is only the teaching for the remaining students. So the particular topic desired for particular person, that particular person make others to be a master of that particular area. Now what I have decided, next class onwards, I will give the subject to students to teach. Then you people know. Then automatically you all will sit and study, na? People got any practical dates?
No, ma'am.
No, ma'am.
So it will be there after or second or third week of April. These are tentative date only, no clear date. Anyhow, whatever we wanted to do, we cannot do, isn't it? Huh? Still, we are waiting for people to join. Anyone in contact Harshita? No, she is not ready to join.
Ma'am, she's outside. She said she'll try. You just spoke to her, no, ma'am?
I didn't say. I spoke to this Durgesh.
Acha, Durgesh. Okay.
Yeah. He said, ma'am.
She said she will try to join. I thought you were speaking to Harshita.
I told you, every day evening we will have class throughout this week. Only the time will be half an hour plus or minus.
Yes, ma'am. Ma'am, we can start. We don't have to wait, ma'am.
Okay, then that's my opinion.
We have already waited for 33 minutes, 23 minutes.
Sir, okay, we'll start. Sorry, now you people have to define technically what is meant by disinfection. Madam, yesterday I have started again. Don't ask me, don't say that. How you could observe from me, I should know that. That's what I am asking you. How you people can define what is meant by disinfection? Technically, you have to define.
It is the removal of bacteria and any harmful substances from the water, ma'am, to make it safe for drinking.
Okay.
Yes, ma'am. Removal of harmful germs or bacteria from the water.
Okay. Anybody else? You people answered correct, but you won't get 100% mark. It is not removal. Removal will not be giving 100% efficiency. It is killing of bacteria or other germs. That is called disinfection. You understand? Can you differentiate the meaning of these two terms? For example, I will tell you, you are removing the color from the water. The color you can remove up to your acceptable level, that I agree with you. But we cannot assure that 100% you have removed. 1 or 2% or 3% or 1.5 or less than 1%, it must be written with that, because the color which is imparted from the phenolic compound, which is influenced with the bond or structure level, that could not be removed. Understand? It may be less than 1% or less than 0.5%, but something must be there. But when we are coming into the point of disinfection, we have to kill the substance totally. It became inactive. Understand?
Yes,
removal cannot give 100% efficiency. Killing means we cannot say no. Only 50% we killed, 45% killed. Killed means the organism is completely killed. That is called killing, isn't it?
Yes,
the killing of infectious bacteria in the water, and with that process makes the water safe to use. That is called a disinfection. Clear that? Till now we have whatever the steps of water treatment we have studied, even from the screening to filtration, of everywhere you can use the term removal, removes. But when you are talking about the disinfection process, you should use the term completely making the organism to inactive, or you are killing the organism totally, you have to say. Don't say that remove. Clear? After you killing this substance, if the population is more, means you have to remove by some filtration technique. If you understand the difference.
Yeah.
Okay. Okay, now we'll go ahead. Then more than that, I can't. As I told you yesterday, whatever the physiochemical characteristics like color, turbidity, even odor, and other chemicals such as colloidal particles, turbid particles, those chemicals present in water which does not give that much dangerous to the human health. But the presence of this pathogenic bacteria and the other microorganisms, because which leads to the spread of some sort of epidemic diseases like cholera, dysentery. You know that cholera, dysentery, and typhoid, those are all called epidemic diseases. Why you know that? Come fast, little. Those
What, ma'am?
diseases spread at, what are the waterborne diseases?
What about cholera, diarrhea, and
cholera, diarrhea, yes, correct only. And the
and,
typhoid,
typhoid. And so to some extent, hepatitis also.
Yeah, the diseases which are, yeah, jaundice also. Yes, correct. These are all waterborne diseases. If you people are drinking safe water, that means completely free from these pathogens, all these epidemic diseases will not spread. So you people be clear. Hereafter, if you are not getting any good filter water, at least you just boil the water and drink, nothing will happen. So if the temperature rises more than 78 or 800 degrees centigrade, all these germs will be killed totally. If you boil the water, it maybe reaches 80 to 90 degrees centigrade, and none of the organism will be alive. It will be inactive if it is here also. Then if you drink that water, nothing will happen. Try to have that habit. This is the outcome of this unit study. Okay. So chemicals are substances, some of them used for this process of killing this infectious material or infectious substances or bacteria is called disinfectant. What are those disinfectant? In detail, we'll see in this particular unit. Still till date, in many rural area people, they are depending on this tube wells or open well or canal feed water only for the drinking water supply. Those water, usually we can say that they may be free from color and turbidity, but we cannot say that they are free from microbes. So they may not require the whatever the physiochemical treatment we have given, but it must be treated with some chemical for doing this disinfection process. But well water is generally available in all the season, and it is more suitable water source in rural area till date. What people are doing, they are taking the water from the well, make use of some bucket and rope, and many buckets they at a time people are using and taking. So there is more possibility to contaminate the water. But those water really are free from some other turbid material, whatever there in urban area. But still the water is contaminated. They are advising us to do the disinfection process before consuming that water will be good. In the well, they cannot do the disinfection. So after taking the water from the disinfection, they can do the disinfection process at home by boiling or something else. Why I am telling this point, whoever linked with the rural area, if the people are drinking that water directly, means you can just advise them just to heat the water and drink, you can advise them. Because the waterborne diseases are very killing diseases. That's what they are telling that epidemics. Once either jaundice, typhoid, dysentery, cholera, all these diseases are coming, the people will cure also. Because of that, treatment medicine will have some side effects when they become old. That right now they cannot absorb, but in age old they will have some side effects. Immediately that will not be reflected, but later on it will have some side effects here and there. Exactly, we cannot say where it is. So that's what I'm telling. In the area covered by canal irrigation, especially in hill areas and all, canal water is being used as a drinking water. But naturally, their plain sedimentation and parallelly natural disinfection is taking place. But whatever it may be, due to this pollution and the movement of these gaseous polluted moving from one place to another place and deposited at any times because of condensation, so none of the water source we can say that is cannot be relayed. This particular source is good and we can use that water directly for human consumption. Like that source of water, nothing is available. We can say some of the spring which comes out of some hilly areas may be good enough. But some of the water we are taking from the underground also is contaminated with many things. So the water is continuously disinfected, means it will be good enough to maintain the human health, especially in this modernized world. Sometimes villages carry water from the tank and which it is carried by the pipeline to the homes. Even then that water is supposed to be disinfected. Anyhow, whatever the unit process involved for the treatment, that is like flagellation, sedimentation, filtration, whatever it may be.
You mean that, ma'am, you mean that even after passing the water table, still pathogens will be there in the water?
Water table in the sense from the ground.
Yeah.
Yeah. Yes. You know that that the topmost soil of water, that is called water table. That is from the surface, it is penetrate through the subsoil. We can't assure that only water went. Along the microbes it went, because microbes is there everywhere. Human beings are there only in specified place, but microbes are there everywhere. There is no place constraint for them. Even if you are doing any sort of sterilization also, the sterilization will be free for only few hours. Even in my this operation theater, that places and all people are doing sterilization. There is a time limitation. This many hours only be free from the pathogens or microbes. After that, because of movement of air, that will be contaminated. That's what again they will do humidification, dehumidification, continuously they will do. Understand?
Yeah, ma'am.
Okay. So that's whatever the unit process till now we have discussed, that is called coagulation, sedimentation, filtration, many things. Those water are chemically and aseptically it is acceptable, no problem at all. But which has some microbes, so the reduction or the complete elimination or complete killing of this bacterial content also it is very important. That's what these people are saying, that whatever it may be the source, we have to make the microorganism to be totally inactive, and all this disease producing bacteria will be inactive in water. Then you drinking means nothing will happen to any living things, not only for us, even if you feed to the animal also nothing will happen. Okay, this is about the brief introduction about the disinfection process, why we have to do, how we have to do. Why we have to do, I said how we have to do, and how it is working we will see. The principle involved behind the disinfection process we will see. Each and every process, whatever it may be, the physiochemical process or biochemical process or biological process, some factors will be influencing on them to increase the rate of the process or decrease the rate of the process. Those are all called factors influencing on the process. Now we are talking about the disinfection. So it is called factors influencing on disinfection process. You people can open the slide. I'm going to tell about some equation. You just have a look. So there are 4 important factors influencing on the disinfection process. One is time of contact. Time of contact of what? I'll tell you. Then concentration of disinfectant. Then concentration of microorganism in the water. Then the temperature of disinfection process. What is time of contact? According to one scientist, he derived one equation which tells that the number of organisms destroyed in unit time. Unit time means 1 second, 1 minute, okay, is proportional to the number of organisms remaining in the water. Actually, according to the disinfection process, the number of organisms destroyed in unit time, because that means within unit time, all the microorganisms cannot be killed. It takes time. That you can understand from this. And 1 minute may how much it is destroyed, which is proportional to the number of organisms remaining in the water content. That is being expressed ln nt by n0 equal to minus k into t to the power m. What does it mean by all those liter? Where n0, which is nothing but the initial number of organisms, ns, which is nothing but the number of organisms remaining after that time, nt you can say, and k is the rate constant, t is the time required for the treatment, and m is also a constant where the number 1 which
proportional means the number of organisms destroyed per unit time. When this is getting destroyed, the same proportion is again increasing.
The number of organisms remaining in the water.
Both will increase. Both, yeah. In unit time, both will increase at a time.
Both increasing, we cannot say, na. It is remaining.
Proportional means if one increases, other also increases.
For example, for 1 minute it destroys 30% means you can count it 30% at the minute. The count it, how much it could be, we cannot say exactly how much number. Whatever it is remaining in that 1 minute for that unit time which is in contact with the disinfectant, that is proportional.
Oh, okay, ma'am.
Understand? So 10% only destroyed in unit time means Whatever the microorganism in contact with the disinfectant, same 10%. Remaining 80% will be there in the water. And the next stage, 20% is destroyed in unit time means, that means 20% in contact with that disinfectant. Then only it can destroy 20%, no?
The water will keep on flowing, no, ma'am.
No, disinfection process will not be. We have to do the process, it retain, and we have to maintain the chlorine level 0.02 to 0.03
okay.
volume, then only it will be distributed.
Okay, ma'am.
Understood?
Yeah, ma'am.
Okay. Because since chlorine is corrosive gas, we cannot do like that.
Yeah.
Yeah, that it has to be maintain that uniform concentration throughout the water content in the tank. If one area it is more, one area it is less, means which gives both the positive and negative impact on human health. If it is more also problematic, if it is less also problematic. That is the problem of this chlorine. Okay, it is a disinfectant, we kill all the microorganisms. So if we add little more, it will be good, you cannot do it. If it is little bit more also, which affect your intestine. Understand? Because it is highly corrosive, which corrode your intestine also if you drink.
I mean, our intestine, some good bacteria are also there. This
yeah, that is E. coli is the...
not
that's why they are maintaining at 0.02 to 0.03. That will not affect any microorganism. If it more, then that is problematic 100%. These are all world level accepted level, not only for Hyderabad. World level accepted level of chlorine for drinking water supply is 0.02 to 0.03 ppm.
Probiotics are there, no ma'am? Probiotics.
So those bacteria will not die at that concentration.
Okay, ma'am.
Already we free from pathogen, those water only we are taking, isn't it?
Yeah.
Then what?
This chlorination, when we take inside after the disinfection is over, that won't affect our E. coli bacteria.
No, that is standard level. Actually, for everything there is a threshold level. Okay. We are using light. Too much of light also not good for health. You know it?
Yeah, ma'am.
Like that. But light is important. Without light, we can't do it. We need light. Without light also, our eye will spoil. Okay, if too much light also, the eye will spoil. So there is a threshold limit for everything. The food is good, but too much of eating is also problematic. Too much less eating also problematic like that. That's what they are telling food poison. So then this will become a food poison if you are adding more chlorine. So you have to maintain such a concentration throughout the process. It is very difficult process. It is not that much easy. Okay. Then did you understand what is time of contact? Time of contact, it is very important concept. The number of organisms destroying is proportional to the number of organisms remaining in the, actually they are contact with the disinfectant. There will be much in the water. Then slowly the process will be going on, or rapidly it is going on, it depends. It depends upon the temperature, it depends upon the concentration of disinfectant, it depends upon the concentration of microorganism. Many things are there. The rate of reaction depends on many factors. One of the thing is very important thing to be observed is the number of organisms destroyed in unit time. That means per minute is proportional to the number of microorganisms remaining or which in contact with the disinfectant. So that is being expressed ln NT divided by ln N0, which is equal to minus K into T to the power M. For expression, they have given the explanation you can have. Next one is concentration.
ln is logarithm.
Logarithm. Ln. It is converted to the logarithm means you have to multiply it with 0.693.
Yeah.
Ln means
why it is
log
minus, ma'am? Why it is minus K, ma'am?
Means in the rate is when the process is keep on going, it is reduced. It will not increase.
Oh, yeah. That is why it is minus.
Yes. So the rate of reaction will be reduced only. It will not be increased. The population concentration will decrease only. It will not increase.
Yeah.
Okay. Then concentration of disinfectant. What is meant by concentration of disinfectant? We are using disinfectant at particular concentration. The concentration selection is depending upon again the concentration of organism present in water. That is being expressed in terms of C to the power n into Tp equal to constant, where C is equal to concentration of disinfectant. Tp is the time required to effect a constant percentage destroy of microorganism. And N is the coefficient of dilution of water, because sometimes what the people do, in case if the water contains lot of microorganisms, they will not do this disinfection directly. They will add with water to bring down the concentration of microorganism. That is called a dilution. So the dilution factor, if we are doing dilution means we have to consider the dilution. That is A. And the measure of order of reaction equal to, for this particular reaction, it is being standardized, that value is 0.86. The next one is concentration of organisms. How you have to express this? That is expressed in terms of C to the power Q into NP equal to constant, where C equal to concentration of disinfectant and NP equal to concentration of organism reduced by a given percentage of or given percentage dose of disinfectant in a given time or given process time. Q equal to coefficient of disinfectant, strength or concentration of disinfectant. The next important parameter is temperature. Temperature is only the process always decide the rate of the reaction. So how fast this disinfection process will be carried out or taken place depends upon the expression log T1 by T2 equal to E into T2 minus T1 divided by some constant into temperature difference. Okay. T1, T2, by the name you can understand that it is time required for equal percentage of killing of microorganism at a fixed concentration of chemical. And T1, T2, the two absolute temperature, the initial and final temperature of the process are being noted for comparison. E is where whatever the process we are carrying out, if there is absorption of heat or desorption or emission of heat will be taken place. So the energy will be absorbed or released. That will be quantified in terms of activation energy. Clear? These are the things you people have to study. No other option.
Yeah.
If you have any doubt, we can ask.
No, ma'am.
Okay. Types of disinfectant. Yes.
And this concentration of disinfectant, you told some 0.86 something, ma'am. What was that, ma'am?
Actually, there are different types of microorganisms. Not only bacteria, not only virus, we can't say, and in virus, what types are there? In bacteria, what types are there? We may know E. coli and what is that one more type will be there? Coliforms. These two only we may know. But there is a n number of bacteria, each and every type, their activity level will be different.
Yeah.
And they have studied this disinfectant concentration to kill the same concentration of microbes, how much it could be. When they have studied like that, for most of the microorganisms, that value equal to constant 0.86%.
No, how is this threshold for the disinfectant is calculated? Means how much disinfectant we have to?
For example, how we can use, suppose you take 1 liter of water. Okay.
Yeah, ma'am.
That 1 liter of water contain how many numbers of microbes you have to analyze. Population count is there, plate count. In 1 ml or 1 liter of microorganism water, how many number of pathogen or E. coli are there or coliforms are there, you have the separate test. You have to do the test. Based on that population, you have to add how many molecules of chlorine it needs. So
that's
you
how
know
should
the
be calculated.
Yeah, you know the concentration of chlorine in what are the source of chlorine you are going to be used. Either you may use bleaching powder or chlorine dioxide, hypochloric acid, whatever it may be. In each and every chemical that contains a different percentage or concentration of chlorine, that concentration and the concentration of our population strength, based on that you have to add the chemical. Okay, this is general. In that also, some of the microorganisms will kill at low concentration. Some of the microorganisms will kill at the higher end of concentration. When they are undergoing those studies, at 0.86% people have observed that most of the organism is killed at that concentration they are telling. That concentration which makes the water totally free from pathogens.
Okay.
Clear?
Again,
I am telling you this.
Yeah.
Yes,
just like water boils at 100 degrees Celsius. This is just like that only, that 0.86%. Most of the
all the microorganisms, it is not usually 99 they are telling. They have given one value, most 99% kill of organism.
This includes this includes pathogens, virus, everything.
Pathogen means it includes all. Even fungus also means that also will be killed. Fungi is plural, fungus is singular. Fungi is there, fungi is there also, it will be any algal is there also, it will be killed. Any bacteria, virus, everything killed but at that concentration. Understood? Not clear? Okay, no one is responding. Class is over. Bye.
No, ma'am.
Okay. Understood? Is it clear?
Yes, ma'am, it's clear.
Okay. Then types of disinfection. Can we jump?
Yes, ma'am.
Okay, there are different types of disinfection are there. One is physical disinfection, another one is chemical disinfection. You can ask me the question, ma'am, physically how we can do the disinfection? You can ask me, but I myself have explained many times that water boiling is the best method to do this disinfection. That is our age-old process, but it is a time-honored practice to destroy a pathogenic microorganism. And it is a safe method also, no one can question on it. Like that, it's very, very important, and also it is honored process of killing pathogenic microorganism. Okay, what are the different physical methods of disinfection is? By heat we can do, by light we can do, by ultrasonic waves we can do this disinfection process. It is very excellent to discuss, we will enjoy. Okay, one by one we'll see. By heat. Now again we will ask you, anyone can tell how we can do this disinfection by heat?
By boiling, ma'am.
Yeah, only by boiling, make the water boil or bring the boiling water. Then safe, that is the safe and a time-honored practice. When in your book they have given excellently, and that destroys pathogenic microorganisms totally. It is very effective process at a high flow level treatment. But when we are coming into that community water supply system, it is highly impractical and technically not feasible. We cannot boil that entire Hyderabad water supply water, isn't it? Yes. So at a household level, it is possible. The next one is by light. We all know that sunlight is a very good natural disinfectant. Practically, it is a very...
Which one, ma'am?
Sunlight.
Sunlight, okay. Yeah. UV radiation.
Everywhere UV radiation is coming means then we cannot survive, sir.
No, ma'am, for disinfection, ma'am.
Sunlight is a nature disinfectant means that is the reason people are telling that you put your clothes under sunlight for proper drying. But why they are telling that? Because it is a disinfectant and also it is a good desiccant. What is meant by desiccant?
Desiccant means I have seen desiccants in my lab. Desiccant.
What is
desiccant is something which yeah, ma'am. Desiccant means like, it absorbs. Yes, this what to tell. How to tell?
No, it will not absorb.
No, ma'am. Desiccant. It won't allow the
other things to enter
air to enter inside.
Water. It dries whatever substance it is putting in it, ma'am.
It will keep it the state of dryness.
It will not provide moisture. It will not let that thing become full of moisture, ma'am.
Yes, actually, exact meaning of that is it maintains its own humidity. It will not allow to interfere external things into inside. It is a sort of container which protect the substance in their own environment. It will not allow to foreign bodies enter inside.
Yeah.
Okay, that is called desiccant. Then why they are telling sunlight is a desiccant? Is it true? Yes, it is true. But we have destroyed our own environment that became, even then the sunlight is killing unwanted things which we have created. It is a good desiccant, but we have destroyed the things. So because of that, ozone hole formed. Through that, many unwanted rays are coming, and we are making unsafe of our entire ecology. That is true. Okay. But one more thing I would like to say, irradiation by ultraviolet light, which intensifies the disinfection process. How we can do that process, we'll see. Actually, when we are making the thin film of water, and which is exposed to that light, and the thin film of water is about 120 millimeter thick, then you can imagine it how much it could be, 1.2 centimeter thick only. To one or several parts mercury vapor arc lamp emitting the invisible light and to that water, then which gives the disinfection effective on the water. Actually, this method is very, very efficient method, and we have to expose the light for very short period of time. When we are doing such a process, there is no introduction of any foreign material on the water, and no taste and color are produced by the process into the water. And sometimes if you do overexposure also, nothing harmful effect will be reflected on the water quality. So this much good effectiveness will there by that ultraviolet light intensification process. But whatever it may be, its effectiveness slightly reduced whenever the water contains too much of turbid in the form of nitrate, sulfate, and ferrous ions. Even then, it produces no residual effect that would protect the water against the new contamination. But this method is a very good method, but the country like India, we cannot afford, but still in many developed countries adopted this method for doing the water disinfection process. You got it what I said?
Yes, ma'am.
Yeah,
it is very, very good process, and it is economically not feasible like the country like India or developing countries. For developed countries, it is good. And another important process is ultrasonic waves. Ultrasonic waves means they are using the waves at very high frequency level when they are providing into the water, which give the sterile effect into the water. What is sterile effect?
Oh. Ma'am, sonicators are the same, no? Sonicators.
Sonicators which give the effect to remove the air from the water are content. Sonication.
Oh.
I am saying that sterilization. Sterilization is different. What is meant by sterilization?
Ma'am, it's free from bacteria or
free from bacteria, ma'am.
Germs, ma'am.
Yeah, very good, very good. Okay, sterilization means again killing of microorganism is called sterilization. Okay, how they are killing? Any one of you know about the sterilizer, sterilization, and some water bath?
Water baths, you know, but normal water baths, they use in labs, you know.
Nowadays, only people have introduced this disposable needles, isn't it? 10, 15 years before only, or 20 years before only, they have introduced. Before that, how the needles have been used, you know?
They were
in India. How the people have used? They have reused the needles. That also, you know.
Yeah, ma'am.
Days 15, 20 years before, nowadays it will not be available. It won't be or don't be available. I think so. Even I have seen when I was very small, people have used the needle repeatedly. Before using that needle, they will sterile it nicely. How they will sterile? They put the needle after usage, they wipe with some cotton. After wiping, they put it into the boiled water. In the boiled water, they think that all the microorganisms or blood cells will be killed totally. Then it is safe to use, they found. But how far it is good, I do not know. You people know that what is meant by autoclave?
Autoclave I have seen.
Yes,
in
ma'am.
our
In
university.
microbiology, we use for.
I have seen autoclaves, but I think that is for.
In microbiology, we use that, ma'am.
Yeah.
What in microbiology, in chemistry, or in physics, or in whatever it may, what for you are doing that?
For killing the bacteria and the virus, ma'am. It is for sterilization.
Yeah, that is called sterilization. I want to say that.
Yeah.
Okay. Autoclave, it is a unit in a control pressure of more than 1 kg pressure, around 2 kg pressure, more than 120 degrees centigrade. You are keeping that to kill the microorganism, any sort of microorganism. Okay. There, what is happening? The same sterilization process is happening. That unit is called autoclave. The process which is taken inside the autoclave is sterilization.
Sterilization. Yes, ma'am.
Okay. And another way I would like to say, any one of you have seen or heard about UV chamber or ultraviolet chamber or UV flow hood?
Yes, ma'am.
No? Some unit is there.
UV chamber.
Okay. Yeah, UV chamber. What is the use of it? You tell them, everyone will hear you.
Ma'am, UV chamber is also basically, it is used for, it is also a type of sterilization only, ma'am.
It uses electromagnetic energy, ma'am.
Yeah. Yeah, no. No. Ultraviolet light will come. Ultraviolet light. Yeah, the UV means ultraviolet, madam. UV, ultraviolet.
Yes, ma'am, UV.
Okay, UV light is coming. The people who are all, what are all work is undergoing in biology and microbiology and biotechnology, yes, they have to do in a constrained things for particular microorganism or some organism, including human cell, blood cell, plant
DNA,
cell, animal
RNA,
cell,
yes, ma'am.
anything could be that is, okay.
Yes, ma'am.
When they are doing the work, nothing should be involved, interfered, any sort of contamination should not be there. It is free from that polluted environment or air, because air contains crores and crores of microorganisms. We do not know how many, what are they are there. So if they wanted to do any sort of work, even cloning, hybridization, whatever it may be the work, that should not be contaminated with anything else. They are carrying out the work in a complete sterile environment. Complete sterile environment, how we can make, like operation theater, we cannot do every day, isn't it? So what they are doing, the unit people have designed specifically for doing this kind of work, that is called UV chamber or laminar flow hood, where the light is being provided.
Glove boxes cannot be used, right?
What is gloves? You can use it. It depends on you.
No, ma'am. There are glove boxes. No, ma'am. Glove boxes.
I could not understand what you are telling. I thought it's gloves. Yeah, what did you say? What are you saying, please?
There is a setup which is called glove box, ma'am, where we make this environment. No, that what you're talking about, environment.
Okay, what is
glove
the name?
Box.
I don't know.
Glove box. That is called glove box.
You can you circulate the term in the group. Let us see. Even it is a new term for me also.
In chemistry, we have glove boxes, where there are two kinds to set up it with one hand setup with with 2 hands. We make the set in the setup only. We do it. I will send you the photo.
Okay, with the name you please. Okay, such a unit people have designed. Even then, one more important step I am going to tell. From that unit, some light will come. That light is in the form of ultraviolet light. Even then, they cannot use it directly from our hand, and whatever the test tubes and whatever the spatulas or instrument we are using for doing that work, that also contains some microorganism. So nothing should be contaminated. For that concept, they will use some alcohol, ethanol. They wipe up that entire flow hood unit or laminar flow hood, or you can say UV chamber. Entire flow chamber, it is being wipe up with the alcohol, then only they do this work. Now my question is, why they are using alcohol? Have you seen anywhere the people are using alcohol as a disinfectant?
In hospitals,
also little bit alcohol percentage will be there.
Yes. Very good, very good.
Spirit,
yeah, that
spirit,
is in the form of spirit means, which is nothing but alcohol only. Okay, so spirit
absolute,
only because spirit is very good disinfectant at the concentration of 70 and above. One beauty is there about that alcohol. I will tell you little later. If I forget, means please remind me. Then they will clear up with that unit. Then only they do the work. Alcohol is very good fuel. I said it is a good solvent. Alcohol, again I will tell you. One more side, we will say community basis. It is a good drinks. That's why people are preferring to drink. And another one is, it is a very good fuel when it is blended with diesel or petrol. And after starting up the engine, without that also we can run. And it is a good disinfectant. And another thing, it is a very good solvent. And it is a base chemical for many organic compounds. Even if you see that medical chemistry, alcohol-based product, many are there, even food industry also. Out of all those things, I would like to say this alcohol can be used preferably at exactly 70% concentration only casually. If we increase the 1% of concentration or little more than that, it catches fire easily like petrol. You got my point?
Yeah.
Yes, ma'am.
Okay. So wherever the people are using, even in a hospital, laboratory, as a spirit on the name of spirit or alcohol, whatever it may be, they are
Sanitizer,
using.
ma'am.
Huh?
Sanitizers also they use. Sanitizer, ma'am.
Yeah, that is alcohol, spirit only now.
Yeah,
That
yeah.
recently after Corona introduced, we are using that sanitizer term. Earlier days, no one using that term, isn't it? Only chemical people use that sanitization. Okay, everything is alcohol. So if you use the concentration little bigger, more than 70%, it easily catches fire like petrol. This is what only I wanted to tell. Okay, okay. Then shall we go into the chemical disinfection?
Yes, ma'am.
Yeah.
Okay. So the chemical disinfection, by the name, we can understand that by using of some chemicals or several chemicals, the disinfection process is being done. What are those chemicals? We'll see. Some of the oxidizing agents or oxidizing chemicals like halogens. What are the halogens? Halogens means what are the halogens under comes this category? Chlorine, bromine, iodine.
Chlorine, bromine, iodine.
Yeah. Yes, chlorine, bromine, and iodine. And other oxidizing agent like ozone also could be a good disinfectant. And some other oxidizing agent like potassium permanganate and hydrogen peroxide. These are all the chemical are having the disinfectant quality. But what extent it could be used, we'll see. And metals ion, something like silver ion, copper ion, these are also having the effect of killing microorganism. Alkalis and acids are also having the same effect. Surface active chemicals. Can you give an examples for surface active chemicals? Surface active, I myself told you in class many times. Surface active chemicals or surfactant means what?
Surfactant.
So, okay, leave it. We don't waste time, we will go ahead. Now, we one by one will discuss. First, oxidizing chemicals. All of you have opened your slides. Can you look at that? According to the slides only I am explaining, or here and there I am jumping?
Oh,
okay. Oxidizing chemicals. One by one we'll see. First one is halogens. What are they? Chlorine, bromine, and iodine. All the three are having the same effect of killing the microorganism. But the extension of killing microorganism and the extension of usage of those chemicals and the side effects are different. That's what those chemicals cannot be used for commercial water supply system. We'll see. Among the halogens, this chlorine gas and chlorine compounds are economically the most useful chemical than other halogens. Either it can be used in the form of chlorine dioxide or chlorine gases people are preferred to use. This chlorine dioxide, when we are using, which produces no taste and odor, but it has to be used instantly as it is unstable, because it is unstable state. When we are using this will be immediately as soon as we add into the water, it will be converted into other form. So the pH of the water will be playing the major role when we are using this chlorine dioxide as a disinfectant chemical. Because when we are using this ClO2, the chlorine dioxide formula is ClO2. Is superior to using equal concentration of free chlorine or free chlorine gases when dealing with the alkaline water of pH 7. because I told you that there are two chemicals can be preferably used in chlorine gases, that is chlorine dioxide and chlorine free gas. When we wanted to use this chemical, the pH of the water is supposed to be in alkaline range at pH 7.5. If you use the bromine or iodine, that can be used very limited scale for the disinfection process or swimming pool water, something like that only. Some people are using iodine tablets at the individual level, but when we are considering about the mass scale or commercial scale level, it is not possible. And people are using ozone is also can be the disinfectant because this is non-carcinogenic, but relatively very expensive to do that ozone related disinfection process. But sometimes people are using instant use and it does not have any change and color problem when we are using this ozone. Only the problem associated with ozone usage is expensive. And potassium permanganate, it is a disinfectant, but not more effective disinfectant. And also it is very expensive. What is the color of potassium permanganate? Anyone can tell me, please?
Pink, ma'am.
Yeah,
Right.
pink.
Pink color.
Yes, yes. When we are using this potassium permanganate for water treatment, it imparts the color to the water, isn't it? Color, yes. Odor, taste, everything will be changed. That could be the another reason it is eliminated. And hydrogen peroxide. Hydrogen peroxide is a very good oxidant and it is a poor disinfectant. It has disinfectant quality, but it is not that much effective. And these are all about the halogens and other oxidants of disinfectant properties for disinfection process. Next one is metal ions. The people know that earlier days, until now in some places, in some people are using silver container for eating, keeping water and all. Are you aware of it?
Yes,
it is very good. It is very good because silver ions are killing that bacteria. That's what they are telling, that silver ions are bactericidal. But it is very costly. That's why everyone cannot afford. So if you are using
copper also, ma'am.
Copper is, I'll tell you, wait. Copper container also people are using, but that is very good for algacidal kill, but it is very weak for bactericidal. If any algal is there, algal growth is there, totally it destroys copper. But bacteria killing, there is a limited rate, not completely. But silver kills totally. That is the difference. However, what it may be pure silver, then what mixed silver, who will prefer? Isn't it?
Yeah.
Okay. But anyhow, copper is cheaper than silver. That's why we are all using copper container. Copper container is also good. I can't say that is bad. But silver is dominate than this one. Clear?
Yeah.
And alkalis and acid, by the name itself, we can say if you add some acid means that many microbes cannot survive. That we know that. But see what is the impact of it. If you exposure any organism either to higher acidic level or higher alkaline level, those microorganisms cannot survive for quite a longer time. Okay. For example, when we are doing the water treatment, people will do lime process for softening. If the little more concentration is being added into the water in the form of lime, means that by immediately the disinfection is taking place in the water. That is good, but overdose will give negative effect. That's why people are not preferring this lime process for disinfection. Is it clear?
Yes, ma'am.
Then next one is surface active chemical. Surface active chemical, which is nothing but surfactant. Surfactant means which is nothing but detergents. How many times I have told you in the class?
Yes, ma'am.
Okay.
Yeah,
Detergents are with what will happen? Those are all surface active chemicals. When we are adding the surfactant or detergent into the water,
it dilutes.
It dilutes it. It makes some later, isn't it?
Surfactant.
Yeah, sir. Whatever it may be, not only surfactant, anything. When we are actually, when it forms a layer which provides a more surface area of the product. So when we are putting that cloth into that, each and every molecule which are highly exposure to the more surface area of the detergent. Understand? No,
Yes,
not
ma'am.
clear?
Yes, ma'am.
Yeah, because of that reason only your cloth is getting clear it off. So whatever the microbes related dirtiness and the non-microbes related dirtiness, everything is going up, go away because of this concept only. And this detergents are surface active chemicals which contain both anionic and cationic properties. The cationic detergents are very strong and they are all destructive, neutral detergent, highly destructive if you are choose the cationic based detergents.
Ma'am, they are called Michelle, no, ma'am?
Huh?
Michelle, no? Michelle, Michelle. It's in detergents.
Whatever these things are coming out of soap, what is that? Nathan?
Ma'am, and Michelle will form, no, ma'am, when detergents are used in water, and Michelle will be formed, and all the dust and whatever that would be there will get attracted to that Michelle.
Michelle, what is that? Whatever the dirts are coming out, that will attach to it later. That is called Michelle, which is nothing but whatever the coagulation plug we said. Plug means what?
Yeah,
whatever the dirt particles are there in water, it is come and attached with that surfactant there in the form of coagulant. Then that will be aggregating each and every particle. It became the similar concept here. This will be behaving like an individual entity, but flagellation will not be behaving like an individual entity. That is mass flag. Understood? Okay. That is the difference. Okay, very good. People are correlating nicely. And there are different types of detergent, sometimes cationic, anionic, and neutral detergents. 3 types of detergents are available. These cationic detergents are strongly destructive. Neutral detergents are intermediate. Anionic detergents are very weak in their action. So detergents are usually, basically people are using for, when we are using the detergent for washing and cleaning the utensils, that time only it is coming out from different places. Those will give the disinfection process, but even then, the effectiveness of disinfectant from the cloth by surface actant is more than the disinfectant effect of surface active chemicals from the other regions. Like whatever I have told, even we are washing the utensils, cleaning the utensils, many things we are doing with the detergent. That effect will not be 100%. We cannot assure that. Is it clear?
Yes,
so if people use these surface active chemicals for cleaning of any utensils, please stop it. Choose something else. Washing powder, it's good. If you take little also, it is washing cleaning. Don't say please. So now we have seen many methods of disinfection. Among them, which one is good you feel? That is a question for you all.
Ma'am, oxidizing chemicals.
Okay, oxidizing chemicals, which one is particular? We have discussed.
Chlorine, ma'am.
Yes, excellent. Okay, good. Now we have studied, I have told you many types of disinfection. Physical disinfection we have seen. All the physical method is good, but the only thing is water boiling is not technically feasible. Lighting method is good, but that is not economically feasible. Ultrasonic waves, it is also very good, but it is highly expensive. We cannot afford, but all the 3 methods are really, really effective method of disinfection. When the practicability is coming, it is not feasible, so we have omitted. For a country like India, in some developing country, people are following that, and the individual, some hospital level, individual level, and all people are following that techniques. So we have to go as per our economic status, chemical disinfection. When identifying the chemical disinfectant, many chemicals are there. That's what we have discussed. Among them, oxidizing agents and surface active chemicals are good. Normal usage at a domestic level, metal ions like a silver container and copper containers are good to some extent. But when we are coming into the large scale level, oxidizing chemical is preferred. Among the oxidizing chemicals in terms of feasibility, technical feasibility, availability, and health-related uses, technical feasibility and economic feasibility, chlorine and chlorine compounds are effective in terms of many things, which does not produce any taste and odor, and also it can be used in wide range. That is the reason people have preferred this chlorine as a disinfectant at the large scale level. So the process is called chlorination, and about the chlorination hereafter we'll discuss. Okay, chlorination. You know that in this chlorination is being the water in disinfection process. It was first used in New Jersey City in USA. That is in the year 1908, 19th century only. It is wonder, na?
Yes, ma'am.
115 years or 115 years only this technology is being commercialized. The first they have adopted in New Jersey, USA, 1908 only. Because many reasons are there, we'll see. Chlorine is a greenish yellow toxic gas. It is not a clean gas. It is a toxic gas found in nature only in the combined states. We know that where the abundant chlorine is available. Abundant chlorine, where it is available and in what form it is available on the surface. Earth surface.
No, ma'am.
Very good. Kneel down, everyone. Every day we are using something for our cooking and eating that is called salt. What is salt? Chemical name of salt.
Yeah. Sorry, NaCl. Correct.
Sodium chloride, ma'am. Sorry.
One is saying NaCl, another one is saying salt, and no one is saying sodium chloride. All are same only. Okay, good. Very good. Okay, so that is abundantly available in our Earth surface, but it won't be available in free form. That will be available in combined form or combined state only. Clear? The examples, abundant of sodium chloride is available. Chloride is available, that is in the form of sodium chloride only. Because it has the penetrating and irritating odor nature, and it is heavier than water, and it can be compressed to form a clear amber colored liquid at very high pressure. I told you, if you compress the gas, means it will be a liquid.
Yes, ma'am.
I didn't tell. Any
Yes,
example can you tell me? You are using LPG gas, no? That is gas or liquid?
Yes, ma'am.
Gas.
Compressed natural gas, ma'am.
Liquefied petroleum gas.
Liquefied petroleum gas.
Okay, that is gas or liquid I have asked. She said it is gas. What is others answer?
Liquefied petroleum gas, ma'am.
Yes. Okay. But as of me, it is liquid. Okay. I will give an example. When it is in the cylinder, that is completely compressed, that is available in the form of liquid. When it just come out of the cylinder, it became gas.
Regulator.
That's what that is called liquefied petroleum. That is in the liquefied form, but you are using as in the state of gas. Understood?
Yeah.
Not understanding.
Understand.
Nubia.
Understanding, ma'am.
Okay. Did I tell in the class? I never told you this concept in the class.
Maybe once, no, but not in detail, ma'am.
Okay. This is liquefied petroleum gas. In the cylinder, it is compressed, so it is available in the form of liquid. Otherwise, it cannot be filled in the cylinder. Yeah, isn't it? How you fill in the cylinder? After filling up, it is still the pressure is maintained. When it is coming out of the cylinder, that time itself it became a gas. Clear?
Yeah, ma'am.
Yeah, I have explained this. This LPG gas is odor or odorless?
Odorless, ma'am. You have to give some chemicals to know if it's leaking or not, ma'am. It's odorless.
That she could remember. Very good. I appreciate you. Yeah. Okay. The people is adding some chemical that is in the name of mercaptan. mercaptan, so to find out the gas is leaked or not. Actually, this LPG gas is colorless, odorless, tasteless. But how you will understand? But it is highly flammable gas. If it leaks, it catches fire easily because that is petroleum gas. So to identify the leaks, to avoid this explosive, they are adding some chemicals into the gas while filling the cylinder. That chemical is called mercaptan. If leak is there, that mercaptan smell will come. From that, we could identify that the gas leakage is taking place in particular place. Understand?
Yeah.
Okay. Then when we are compressed, this chlorine gas is also, which forms like a clear amber colored liquid. It became a liquid gas. Okay. And dry chlorine is highly non-corrosive, but in the presence of moisture, it becomes highly corrosive. Dry gas means the gas is without any moisture or humidity. It will be non-corrosive, but a little moisture also, it became highly corrosive gas. And it is slightly soluble in water. Here, 2-3 techniques you would have learned. One is the chlorine is available in the state of combined form, and it is colorless and odorless. It is a colorless gas, but little penetrating and irritating odor. It is heavier than air, so it can be easily compressed. When we are compressing, which forms like a clear amber color liquid. And a dry gas is completely non-corrosive, but little moisture is there means it is highly corrosive gas. All these points, you please keep it in your mind. And this gas is slightly soluble in water. Keep all these things in your mind. Then we'll go ahead in the next issue. That is chlorine-water reaction. When we are adding chlorine into the water, how the reaction is taking place. We will start means this is particular important stage of chlorination. We can't finish before 8 o'clock. What we'll do? No one is opening.
I don't know.
Even I wanted to finish my syllabus, but is it quite interesting or not?
Yes, this is nice, ma'am. Better than filters. This we can understand easily.
The filters means different technical terms are involved that we cannot blame on the subject.
Yes, ma'am. This is nice.
Always you are eating sambar rasam is you are getting bored. That's why you are shifting into some different food, no?
Yes,
hi-fi food, like that. So let us start. I will give overall outline. Then next class we'll start. Actually, chlorine-water reaction is taking place in 2 ways. One is combined residual chlorine formed in the water for disinfection process. Another one is free residual chlorine is formed in water, which also gives the disinfection active. Free residual chlorine means what? And the combined residual chlorine means what? That we will discuss later in detail. If I will start means minimum I need half an hour to explain that. So I will jump now. Now I will handle some other factors. How to use this or apply this chlorine, application of chlorine. We are having the chlorine gas. Either you can use chlorine dioxide or chlorine gas cylinder. How we can use that chlorine for disinfection process. Then how to apply this chlorine for disinfection process we'll discuss now. The most common practice in public water supply is addition of chlorine either in the form of gaseous form or in the form of solution by dissolving the gas chlorine in a small water flow system. Then the chlorine being obtained from the cylinder containing gases under pressure. Then the normal chlorine doses required for disinfection process, which will be wherever the pollutant water is there, the people are using, that would not exceed 2 milligram per liter they are using. And actual chlorine dose requirement is obtained from the chlorine demand test. What is the chlorine demand test? Anyone can say? Casually, can you tell? What is meant by chlorine demand test?
How much chlorine
the concentration of chlorine required for disinfection.
Yeah, disinfection.
Amount of chlorine required for disinfection process.
Yes, ma'am.
That you can say amount of chlorine added to the water. No, that why they are telling the term chlorine demand. That you have to
chlorine
understand
required to oxidize.
No, actually, we are estimating the chlorine content in water. No? That is one of the important physiochemical characteristics of chlorine. If you want to do chlorination also, before doing the chlorination process, you have to estimate how much chlorine is there in the water. Chlorine will be dissolved in water, you know that. We have studied now, it is slightly soluble in water. So some chlorine will be there in water itself. So whenever doing this drinking water quality characterization, this chlorine content also will be estimated. Then it will be estimated in terms of residual chlorine. This is very important information for you people those who are going to write any competitive exam. In what way and what form of chlorine is estimated in water? That is being estimated in the form of residual chlorine. Residual chlorine is different from whatever the chlorine is available in water. Clear? So this chlorine demand means it is the difference between the amount of chlorine added to the water and the amount of residual chlorine after a specified contact period in term. That means you are adding the chlorine into the water, and then the chlorination process is taking place, which takes us sometimes 4 hours, 6 hours, 8 hours contact time. After specified time, how much residual chlorine is there? The difference between these two gives chlorine demand. Understand?
Yes.
Okay. So based on the chlorine demand only, the amount of chlorine is, the first they do the study, then after that only they will add the chlorine. That's what people used to say, that the actual chlorine dose requirement is obtained from the chlorine demand test. Because a million and million gallons of liter people wanted to treat means simply they cannot do. Okay, today 1,000 liters of water is required or 10,000 waters are like that. Okay, 2 cylinders of gas you just pass, it's enough. They can't do something like that. They have to analyze what is the residual chlorine already is there in water. And if we are adding some chlorine means how much residual chlorine is there. Residual chlorine, how much it's supposed to be there in water? I said in many times to you people, how much it is?
Chlorine.
Then after chlorination, how much chlorine should be there in water?
0 to 2 mg.
0.2 to 0.3 milligram per liter supposed to be there. It should not be more than that.
Yeah.
Okay, in your book, somewhere they have written 0.2, somewhere they have written 2. It is 0.2 to 0.3. That is correct value. Okay. So people are listening me or not?
Yes, ma'am.
Yeah, ma'am.
There is a typography error in the book that is 0.2 to 0.3 milligram per liter. Somewhere it is 0.2, somewhere it is 2, 3 will be there. You please correct. And then it is there in book, you write 2 mg, they will underline, they won't give you mark. Okay. On this basis only the chlorine supposed to be added into the water. Then what is the time?
8 o'clock exact, ma'am.
Can we end the meeting or we'll continue the meeting?
Ma'am, the chlorine demand can be measured with instrument.
Chlorine demand?
Can be measured with the instrument, ma'am.
Yeah, there is a method, not instrument. The analytical method is there.
But I have seen, ma'am, in one of the Google images, he is showing an instrument based on spectrometry principle, which is measuring the chlorine demand of water.
Yeah.
Which is measuring the, yeah, ma'am. The range is 0 to 10 mg per liter. I shared the photo, ma'am. I shared the photo on the...
Actually, for chlorine, residual chlorine, nowadays people have developed some method. Earlier, when I was doing water quality studies and all, I have done this colorimetric method. Okay. Colorimetric method means what? We have to make the reagents mix with the water with some color development is there. That color development we have to do in spectrophotometer based on the absorbance, how much concentration would be there in water, we have to compare and find out. That is the method I have used.
Ma'am, is there a specific point at which the complete chlorine demand is met?
My God, chlorine demand means, what did I say? Residual chlorine, how much must be there in water?
There should be a point where the demand is met now. So that way we have to stop there.
Actually, I will tell you.
A break point or something.
Yes, correct question only. I will explain very clear now. When we are doing other treatment, if you want to remove color, odor, taste, and other physiochemical characteristics, everything you have to remove totally. And even when you are doing the disinfection process also, you have to kill all the microorganisms. Okay? If you add anything more or less, if something happened, no issue. You do. In chlorination process, you have to do the process for complete killing of all the microorganisms. And also you should or you must maintain 0.0 to 0.03 milligram per liter of chlorine in water. Otherwise, when the water is being distributed from the distributing point to the end user point, at any point it will be contaminated. If you are maintaining that particular concentration of chlorine, which totally avoid the again infection of the water, to avoid that only, they are maintaining that concentration. In rest of the process, how much you have added, how much you have received or reduced, further you can add and further you can reduce the level of any pollutant. But in this particular pollutant, you have to add the chemical in two concepts. One is it 100% destroy the contaminant, and another concept you should maintain the residual chlorine at the range of 0.02 to 0.3 milligram per liter. On these two bases, you have to add the chlorine into the water. In case when you are maintaining the 0.02 to 0.03 milligram per liter of chlorine gas in water, the microbes cannot be totally killed. Means you have to dilute the water, but you cannot increase the concentration of chlorine. That is the intelligent way to do the process. Did you understand now?
Yeah, madam.
Clear is it? This is people are experienced by doing many experiments, but I am telling very easily for you people to observe. Clear it up. Understand?
Yes, ma'am.
Whatever the concept I said, it will be applicable for many analytical people in their studies. If you wanted to maintain residual value in the product, you can fix the product for residual concentration. You can play with the feed material by dilution. That is a very important concept to doing that intellectual way of analysis or process optimization. It will be helpful, this concept, whatever I said. Okay, then any other question, any other clarification you want? I think many people are not there. Hello, everyone.
Yes, ma'am.
Ma'am,
yes.
Suppose we want to exactly calculate the chlorine demand. So how to do it? Means there is a formula or demand. Dose minus residual.
No, there is a method. For example, through your analytical method, what instrument you are using or operating? You tell me from yours, I will. What instrument?
I'm operating nuclear magnetic resonance.
NMR.
Yeah, NMR.
NMR. Out of it, what you are calculating, estimating or analyzing?
We are analyzing the number of protons and carbons in the organic compound, whatever.
Okay. How many number of carbons there in the organic compound? You are doing that only. Okay.
Protons, carbons, and other nucleosid, which are NMR active.
NMR active. How many carbon? Aliphatic, aromatic, both.
Aromatic, yeah, ma'am.
Okay. Now my question is, there is a method. They cannot directly take from your instrument reading for, suppose you are doing some analysis, some graph will come. From the graph, graph has come, this is 10, spectra, that is called graph or spectra. Spectra, this is 2 gram, this is 4 carbon, that is 5 carbon, this is 6 carbon, you cannot say. There is a method There is a comparable from the standard. From the standard,
we integrate it, ma'am.
Integration. After integration only, you will compare. That is called a comparison with the standard. You are integrating, then you are giving the result. That is the method. Okay.
We take a reference peak, ma'am, and from the reference peak, we calculate it.
Reference peak, which is nothing but a standard peak.
Yeah, PMS.
That means, for example, you can say benzene means whether benzene is there or not, how you will analyze. Benzene peak you should have, that is called reference peak. Okay.
Aromatic, yeah,
then you have compare with that your sample peak. Yeah, it is similar to reference peak, so it is benzene. You will confirm and give the answer.
Yeah.
Like that. Now, from the water, you have to estimate what is the chlorine and residual chlorine. There is a specific method. The chlorine compound will be reacting with some of the compound, which makes a mixture or a particular compound. That compound creates some or which gives some color development. Based on the color development, you can use the spectrophotometer. Based on the absorptions or transmittance, you have to get the peak. As of you will tell that is called a graph or spectra or peak. That will be again compared with the reference graph or reference value, that is called a standard value. Then you get the exact value. This is the standard way. Nowadays, people have something there, photometric method also. Photometric method means photo emitting words people are using, like a sensor that people are using, but they are not giving exact value of residual chlorine. Because residual chlorine means what? Whatever the organic matter present in the water and what are the other reactive material with the easily reactive with the chlorine, all the compound will be reacted and make it as a complex structure of organic compound or organic related chlorine. That chlorine is called residual chlorine. About that only I told you I wanted to have more time to explain. That's what I stopped. Understand? So that residual chlorine you can be calculated based on this photometric, calorimetric only the best method. Even photometric method, how it will be working better way, even I do not know. But caloric method is the best way. How you can use the caloric method? You have to generate or produce some color solution. Each and every color, it has its own absorption. That where the absorption is more, there you have to fix the wavelength of absorptions for particular color. So this color solution, what color it gives, based on the color you have to fix the wavelength. That wavelength you have to operate the different diluted liquid of residual chlorine content sample. You have to analyze, you have to find out the range. Where it is exactly 0.0 to 0.03 milligram per liter is coming. There you have to fix how much chlorine you're supposed to add in a cross calculation. You have to find out and you have to maintain. You have to calculate for this many milligram per liter. Then you have to convert it into 1000 liter, 100 liter, and a million gallons. Like that, you have to multiply and maintain the chlorine level. Did you understand? Hello?
Yeah. Yes, ma'am.
Yeah, ma'am.
Okay. A caloric method is the best method. Nowadays, any sensor method I have found out or not, I do not know. Even then, it will not be working out because this residual chlorine.
Here in Google, he is giving a formula. Residual chlorine is equal to normality of iodine into volume of iodine into 35.45. I think it may be the molecular weight.
Many relation could be found. It is not. I'm saying that now today I am doing some research. You are doing some research. Somebody else will. They can generate n number of relationship.
Okay,
n number of correlation. But what is the standard method? Worldwide agreed, you have to choose. Understand? Many water filters are there. All the water filters are performing on the same performance level. I am asking the question. Please answer to me.
No, ma'am.
No, ma'am.
I have in market many water filters are coming out. People are doing research and finding out something they are making. But if everything is good, means all supposed to give all equal results. So it's not giving like that. Everyday research is going on. Yesterday, what people found, and today what people found. Yesterday, what they are going to find, we do not know. And then tomorrow's things may be better than the old thing. Our old things only the better than the future things. Nothing would be decided. But the standard method is calorimetric method. Understood? That is worldwide agreed method. Everyone is following.
This disinfections also, ma'am. I heard somewhere, I read somewhere, antimicrobial coating they are doing.
Is it possible at large scale level?
I don't think so. I read somewhere, ma'am. This new disinfection process.
I am telling now, for disinfection, we ourselves have studied many chemicals can be used, but all the chemical is being rejected. At last, only one have been selected. One has been selected. Okay, that is the thing. Many today I also can do this as a disinfectant, but it has only 30% efficiency. Tomorrow you can do with some chemical. This also can be a disinfectant, but which has only 40% efficiency. Tomorrow Dubia will do some research. She will say, I found one disinfectant which has 60%. But which one give the best result? That only can be commercialized.
Yeah.
And which is supposed to be feasible in many ways, economically feasible, technically feasible, and it should not have any side effect in terms of color, water, many things are there. Clear?
Yeah. Yeah.
Even I said this silver container is good bacterial side. Everyone can afford.
No, ma'am.
That is the point. Okay, any other question?
No, ma'am.
Sorry, everybody went for cooking, I think so. I also go. Any more question means you people please ask me before I terminate the class.
How to calculate, man, residual chlorine?
There is a formula. If you want me to give the formula, I will give late tomorrow. Please remind me.
Okay, ma'am.
Okay.
Okay, ma'am.
There is a method you can. That is not a difficult thing to find out. The method you have to understand what is meant by residual chlorine. That is my concept. Because people are reporting that chlorine content of this is that much, that is this much. But exactly the chlorine content which reflects in the form of residual chlorine only. The residual chlorine is which is nothing but organic compound form of chlorine that makes that undergoes combined sequence chain reaction at last which gives CCl4 form. Understand? When it is there, it is highly inactive in nature. When that inactiveness will come, then only it is not problematic to the human health. That is very important concept to understand. Estimation anyone can do. Estimation anyway, if you think of 10 minutes about how the things, how it could be calculated, you can find out. But the process understanding is very important.
It is the amount of chlorine which is sufficient to make the bacteria inactivate. That's it.
And also
Bacteria
to maintain residual chlorine in water, 0.02 to 0.03. That's what I repeatedly am telling you. People are catching
yeah.
In other treatment process, you have to control or eliminate and remove. Here, you have to kill the organism as well as you have to maintain certain level in water.
Yeah.
That's what I have explained about the dilution factors also.
Yes, ma'am.
Okay. Any other questions? Okay, thank you. Anything means please ask me. One more or 2 more means I will wait. Dalia, ma'am.
So this residual chlorine, when we add, ma'am, it will protect us from recontamination also.
Yeah, that's what we are maintaining 0.03 milligram to protect. That only we are maintaining that level.
Yeah.
Otherwise, no need. In our water filter, what we are using at home, it does not have any chlorine content.
Yeah.
But whatever the water we are feeding from the corporation water supply, that contains 0.02 to 0.03 milligram per liter of chlorine.
Yeah.
Understand? That we are taking out when we are doing this reverse osmosis process.
Yes, ma'am, you asked me.
Yes, ma'am. Are you there or not? You are keeping quiet like a small kid. That's what I call you. No question, ma'am?
No, ma'am.
Very good. Okay, then shall I close the session or any more question?
No, ma'am. No more questions.
Okay, thank you. Thanks to every one of you.
Thank you.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you.